All right, how's everybody today? Okay, good to see everybody. You have a 3-day weekend. Won't see you again until Tuesday. Um, but don't forget that next Thursday, we have less than a week. We're going to be taking our second exam, and it is just over simplifying the expressions with the identities as we've been practicing for the past couple of weeks. Okay, very similar to a lot of the problems we saw during the game, the quiz yesterday. In fact, I'll pass those out at the end. You guys did a really great job. Your class average was at 95.2, so excellent job. Uh, but the test, just like the quiz, is multiple choice. You're going to be allowed to use your notes. So I'm thinking it's going to be pretty nice because in 2 weeks, what's happening? Oh, nope, it's the end of the 6 weeks. Okay, so hopefully you won't cry yourself to sleep, but not over math. Okay, what was it? All right, so what I want to go ahead and do today, we have our next focus activity for the next set. We already turned in numbers 1 through 3, so we have 4. I've already got 5 and 6 ready, so we're definitely going to have 3 in this set. If I can get more, I'll let you know, but this right here, we'll just hang on to them because now we have a new student. So remember, these we work together, but we hang on to them because at some point we turn them in, and I go ahead and record that as a quiz grade. Okay, so let's take a look. So we're just practicing some more expressions, and these are kind of what you can expect to see on the test next Thursday. So number 1, we have tangent squared of x over 1 minus secant squared of x. And if I go ahead and pull this up, here's all the identities that we've been looking at. Okay, let's talk about that because it does look like it would come from the Pythagorean identity, right? So let me get back over there to the focus activity. So let me write this out. We know that tangent squared of x plus 1 equals secant squared of x. And in fact, who was it who just said that? Okay, Lexi's absolutely right. See, if I want to go ahead and do this, there's just one little detail we're missing. Let me go ahead and subtract the secant squared over here. Okay, so that's going to give me tangent squared of x plus 1 minus secant squared of x is equal to 0 because they cancel. So see, I have the 1 minus secant squared, but I'd want to go ahead and move the tangent over. So Lexi, it would become negative. So if I subtract that from both sides, I have the 1 minus secant squared of x equals negative tangent squared of x. So see, that portion, I have in my expression, I'm just going to replace it with the negative tangent squared. So see, I still have this tangent squared up top, but now 1 minus secant squared is negative tangent squared of x. And this one, we don't even need to rewrite it using a quotient identity or anything. What would it be? Negative 1. You've got the same thing divided by itself, but one's negative, and that is absolutely right. Okay. Questions? No? All right. Number 2, tangent of x plus cotangent of x divided by cotangent of x. You mean go ahead and pull out, like factor it out as a GCF? We could now, that would make this cotangent divided by tangent. I think that's a great idea. Okay, Lexi, say that again. Split them into 2 different fractions. Because we've seen this multiple times. If you're going to add or subtract fractions, you need a what? Well, not GCF. You need a common denominator. Well, that in mathematics is reversible. So these numerators, they both share that cotangent of x, so I could break that apart. I could say tangent of x over cotangent of x. Then we have the plus cotangent of x over cotangent of x. Oh, is that what you were talking about? Oh, okay, because you said factor, and I thought you were actually meant divide it out. Oh, okay. Well, this one right here, that's 1. So I'm going to go ahead and put plus 1. But What can I do for tangent over cotangent? Okay, so let's go ahead and make them fractions. So tangent is, what was that again? So tangent's always sine over cosine. And cotangent is cosine over sine. Okay. Now Lexi's absolutely right. We're going to multiply by the reciprocal. Okay. Now, the more of these, you'll do, you'll get probably to the point where you don't have to write everything out. But if it still helps you, I would encourage you to do it. So sine of x over cosine of x times. Now, the reciprocal of that bottom fraction is sine of x over cosine of x plus 1. There you go. So see, Brandon was able to jump to the final statement. Because when I multiply these, I get sine squared over cosine squared. Sine times sine, cosine times cosine. Now we know that sine divided by cosine is tangent, but sine squared divided by cosine squared would be tangent squared. And that comes from the Pythagorean identity we were just looking at. So it should be secant squared of x. And so, this is the thing. There's always going to be different ways to work these problems. It's not just one method, and that's what can sometimes make it a little more difficult. But it really depends on what you decide to do. One strategy could have you get the answer in maybe 1 or 2 steps. Another strategy could have you finding it in 3 or 4 steps. Okay, so the problems are going to vary as we go through them, depending on what we're given. Okay, good. Any questions on that number 2 or even number 1? All right, so put this in your folder, backpack somewhere where it's going to be safe. In a week or two's time, I will have you turn those in. Okay. All we got to do is hang on to it. I'll save those changes. And here we go. So this is the next lesson. So the good news is I really think this might actually be a little easier because those problems that we were just working on, well, it's kind of hard sometimes to know when to stop. How do we know when we're at our final answer, right? Well, here we're going to go ahead and start looking at equations. So we're going to choose one side of the equation, whether the left or the right, and we're going to try to simplify it just as we've been doing, but to get the other side. So here we're actually going to know what our destination is. We just got to figure out a path to get there. Okay, and we're still using all these identities. We've got the reciprocals, ratio, quotient, Pythagorean, even, odd, and our cofunctions. So the ones that are probably not going to come up too much right now are the even, odd, and the cofunctions. Okay, but the other 3, those categories, those are going to show up a lot. Okay, well, what strategies do we have? Okay, it says pick one side of the equation to work with. Usually it's easier to start with the more complicated side. And I know that seems kind of unusual, but start with the side that has more going on. Okay, the one that's more complicated because there's going to be more options to make it smaller than to take something small and try to go extremely large. Okay, and here's what's really important. Don't work across the equal sign. So like if you have one fraction equal to another, okay, we can't just cross multiply and show that the products are equal. We can't work. We have to work with just one side. Okay. Look for algebraic operations you can perform. We can add or subtract fractions, which means we need to have a what? Common denominator. We could factor something out. That's the greatest common factor. We could distribute. That just means multiplying. We could FOIL. What's FOIL stand for? First, outside, inside, last. We could square terms, multiply by a clever form of 1, okay? Or we could even multiply by conjugates. And this one is actually really useful if you have a fraction where the denominator is a binomial. How many terms in a binomial? Yeah, 2, right? Okay. So what am I talking about when I say conjugates? Uh-huh. Okay. So can you make up an example and give me one? Okay. Think about it like this. The groups are the same except for what? The signs. There we go. That's exactly right. So if we had something like, I don't know, 2x plus 5, 2x minus 5. See, they're identical, but one's a plus, one's a minus. Those are what we call conjugates. Conjugates are a great way to rewrite a fraction. We're going to do that a couple of times here. Now, if you multiply conjugates, then you get a specific type of binomial. What do we call it? Blank of blank? Difference of squares. Yes, it's a circular relationship. If I factor difference of squares, I get conjugates. But if I multiply the conjugates, I get back to the difference of squares. Okay. Look for trig things that you can do. All those identities. So maybe if it's not algebraic, things you've been doing up to this point, maybe one of those identities will be able to help you out. And here are some really easy ones to remember. Cosine times secant is always going to give you 1. Same for sine times cosecant and tangent times cotangent. Because each pair, what are they? Yeah, they're reciprocals. Okay. They are reciprocals. So in fact, take cosine times secant, for example. The reciprocal of secant is 1 over cosine, right? So this would really be 1 over cosine of x, and you'll notice those cosines can cancel, leaving me the 1. The same thing would happen to all the other pairs. Okay. Keep looking at your answer. That's your goal. So you're going to know where your destination is. Question is, how am I going to get from one side to the other? Okay. Remember, there will often be more than one way to verify an identity, and that is absolutely true. I mean, certain identities, certain equations, there are some I could think of 5 or 6 different ways to prove it. Okay, so there's not just one way. The important thing is don't quit. All right. If something doesn't work or it looks like it's going to be too much work, maybe go back and try something else, a different identity or a different strategy. Okay. And this here, when you're finished, put QED at the end of it. Now, quadrate demonstratum, which was to be demonstrated. Okay. But when I was in college and I was working through my proof courses, when we put QED at the end, that just read quite enough done. Okay. Because anybody who's writing out a proof in mathematics, you're trying to justify the rules that we use. Well, anybody reading your work, you want to let them know when you've succeeded in what you set out to do. So QED means there's nothing further to show. This rule is now correct. Does that make sense? Okay. So QED. Qued. Actually, yes, some of my other students were just calling it qued. But you did it. Okay. All right, so let's look at an example, but we're going to do one algebraically first. Okay, so here's the thing. You might remember these back from Algebra 2. This is a rational equation. Now, we're not solving this. Okay, I have no interest in finding what value of x is going to make this true. We're not solving equations. Okay, what I want to do is go ahead and choose one side, either the left or the right, and using either some algebra, some identities, I want to somehow rewrite it just like we've been doing and get the other side. Okay, so this is why I was saying earlier it's always a good idea to start with the more complicated side, because I think it's going to be easier to rewrite this into a 2 than to take a 2 and try to expand it into that. Okay. Well, let me show you how easy this can be. And really, it just depends on your idea. But I'll go ahead and get the ball rolling. Does anybody notice anything about those numerators? They're the same, but they are also some type of group. They are difference of squares. Okay, x squared minus 1. So remember, when we factor difference of squares, we get conjugates. So this first one that has x minus 1 down below, what would the conjugates be? So x plus 1, x minus 1. Then we have this minus right here. Now it's over x plus 1. But x squared minus 1, well, that's going to factor again into the conjugates. X plus 1, x minus 1. Now remember, I'm not even writing equals. We're not solving this equation. I am choosing one side, and I just want to show that it does equal the other side. I want to verify that this is true. Well, does anybody notice anything? Yeah. So I have x minus 1 group factors here, x plus 1 group factors here. So I've got x plus 1 minus x minus 1. Okay. And what am I going to have to do with the parentheses when I drop them? There you go. That's exactly right. I'm going to have to distribute that negative. So this would be x plus 1 because there's nothing out here in front to distribute. So minus x plus 1. Well, what do you notice? Yeah. Okay. And there's 2. And that's exactly what we wanted. That's our goal. But we're just going to be doing this with those expressions we've been looking at for a couple of weeks now. And now we put QED. Quite enough done. You can actually do that. There's a lot of different symbols that people use to signify that they're at the end of their proof. Another common one is to draw a square and then only shade in half of it from a diagonal. That also would mean that we're at the end of our proof. Okay. So quite enough done. Okay. Well, let's take a look at an example. It says, work with the left side, unless the right side is obviously more complicated. And actually, I mean, really, it does not matter. A lot of times, you should be able to go on either side and get the other one. Now, what side do you think is more complicated here? I would definitely say the left. Okay. So I want to take this, just this expression, 1 over cosine squared of beta. And remember, the variable doesn't matter. Could be alpha, could be theta, could be beta. All of the rules will still apply. The variable does not change. Minus 1. So we're choosing to take the left side, and I want to simplify it, but I should get what? Tangent squared. So all these that I give you are going to work out. Okay, somehow, some way, we should be able to get to it. All right. So see how it makes it a little easier? We're still using the identities, but now we know exactly where to stop. Does that make sense? Okay. So how am I going to make this look like a tangent squared? Okay, so we know 1 over cosine is secant. So 1 over cosine squared would be secant squared of beta. Okay. What was that Pythagorean identity again? 1 plus tangent squared. And I'm going to go ahead and stick with beta because that's what they're using. Is equal to secant squared of beta, right? So I can manipulate that rule to look like this. So minus 1, secant squared beta minus 1. That does equal tangent squared. There we go. So the last step should always be whatever side you did not choose. QED. And see, that's the thing. Some of these are very short, very, very quick. Some of them might take a few extra steps. It really just depends on what method you choose. Okay. Oh, broke. Okay, well, let's take a look at another one. Example 3. Prove the identity. So tangent of x plus cotangent of x equals secant of x cosecant of x. This one, we can start with either side, and we should be able to get to the other. The thing is, what can we do first? Do we have an idea for the left or the right? You want to use the right? We can do that. Okay. Okay, so let's see here. Tangent plus cotangent equals secant cosecant. So we are starting with this side, and we want to end up with tangent plus cotangent. Okay. So secant times cosecant. All right. Ideas. So you want to change them to cosine and sine? We could do that. Now, if we keep them as a product, I mean, we could do this. Secant is 1 over cosine of x, right? Cosecant is 1 over sine of x. And I would say that is exactly what you want to do if you're going to choose the right side. Okay, so 1, that would be cosine of x times sine of x. Now, the question is, does anybody see it? There is an identity here that you could use.
Oh, it equals 1 of the plus. Oh, and then
No?
the
Now remember, where's our goal?
our goal is
Tangent plus cotangent. So there is an identity, but this one's not as obvious as some of the other ones we've seen. Is there an identity that uses 1? Okay, now there are several, right? So I would probably want to use an identity that has 1, but that has the same trig functions. Well, we'll get there. Okay, now technically we could do that. All right, but I'm thinking of this one. Let me help you out because I think we're a little stuck. Because we're dealing with cosine and sine, what do those equal? That's why I said this one wasn't as obvious. So I could replace 1 with that binomial right there, right? That's just direct substitution from the identity. Now see, look how we're doing. We need to somehow get a plus in here, and if I were to do that, I'm working my way towards what I need. Okay, so I'm going to replace that 1 with sine squared of x plus cosine squared of x, and it's over cosine of x, sine of x. And now we are very close. And actually, I'll go ahead and say, remember what you did on the focus activity. Oh, now we could cancel if we did something. What did we do on the focus activity? Okay. Remember, don't these two numerators share the denominator? So we can break it apart. Okay, so sine squared of x over cosine x, sine x. Then you got the plus cosine squared over cosine x, sine x. Okay. So see, now that I've split them apart, I can go ahead and cancel those. So see, 1 sine cancels with that one. Cosine cancels with 1 above. What is sine divided by cosine? That's tangent. Plus cosine divided by sine. That's cotangent. Q, E, D. That's why I really like these problems. They're like little puzzles. You know exactly where you have to get to. It's just, how do I get there? Questions? Now, I want to go back in one step just to go ahead and show you. At this point right here, remember I was talking about identities that just had a 1 in it? Okay, bless you. Okay. Now, Brandon brought up another Pythagorean identity. It was tangent squared of x plus 1 equals secant squared of x, right? Well, could I rewrite this to say 1 equals secant squared of x minus tangent squared? Could I have replaced that 1 with this? Absolutely. As long as you're following the rules, I still would have been able to get to that point right there. Now, would it have taken more work or less work to simplify? You know, who knows? But I just want to show you there are a ton of different ways to work these problems. Okay, there's no just one way, and that's what is kind of difficult for some people. Because, you know, when you work problems, when you're working a new one, you can kind of base the pattern off what you see in the other problems, but you really can't do that here. Okay. Questions? Okay. All right. Let's try this one. Okay. So it says match the expression with one of the following. So this one here should become 2 cotangent x cosecant x, or it should become 1 over secant of x. So it's kind of like a multiple choice problem, but there's only 2 choices. Okay. So we got a 50-50. So as you move along in the problem and you use identities or you use some kind of algebra, start to see what shows up. Okay. Anybody want to go ahead and place bets on which one they think it is? Okay, so 2 people already said A. So A?
I bet.
A lot of people are saying A. Okay. Hello. Hey, now what was it?
The quiz from yesterday.
Okay. Give me 1 second, or maybe a few more. Okay. And here you are. Okay. Calculators are right over there if you want to go. Okay. Right behind Jason. Okay. So let's take a look at this right here. 1 over secant of x minus 1. So let me go ahead and rewrite the problem. 1 over secant of x minus 1 plus 1 over secant x. That would be plus 1. Okay. So here's an idea that I always have. If you've got an expression where you are adding or subtracting even, and they're 2 fractions, the first thing I always try is a common denominator. Okay. There you go. And the easiest way to get that is just take the denominators you have and just multiply them together. Now, it might not be the least common denominator, but you'll be able to pull them together. Okay. That's exactly right. Because you'll recognize these guys are what? Oh, when you multiply them, they're difference of squares. They're conjugates right now. There you go. Okay. See, Nathan was sitting out there and he said, "Wait a second, Mr. West." Said, "Wait a second." See, because he. Yeah. Okay. Anyways, so we want the denominator absolutely to look like secant of x minus 1 times secant of x plus 1. And we'll go ahead and multiply those once we get them together. Okay. So here's what I'm doing. This one, whoa. It did that the other day. It just crashed. Well, I'll tell you what, I wonder if the universe is actually telling us something. I would still like to pass back your papers, and I do need to talk to Jalen. Do you guys want to go ahead and stop? Or?
Yeah, we'll stop.
Okay, we'll stop for today. Oh, my God.